Today we're going to talk about how to find the volume of pyramids and cones. Now yesterday we talked about how to find the volume of prisms and cylinders. So to find pyramids and cones we use a very similar triangle, or very similar equation. Again, we're going to use this big B. And this big B we have to remember stands for the area of the base. Okay, that's huge. We got to always remember this. And height again is the height of the pyramid or cone. Okay, that's what H stands for. Now the volume of a pyramid is volume equals 1/3. Remember this, 1/3. Okay, for pyramids and cones, all you do is use the same formula you do for prisms and cylinders, but you put the 1/3 in front, or you divide everything by 3. When I've taught this before, I've always drawn a big pyramid. I actually took a picture of the pyramids of Egypt, and then I inscribed a 1/3 on it, and I hung that up in my classroom. So pyramids and cones are 1/3. So that's the key you have to remember. So let's look at some examples. This one wants us to find the area of a solid. So again, this is a pyramid. So the equation is 1/3, big B H. So in this case, the base is a triangle. So big B is going to be equal to base times height divided by 2. So we could say 4 times 6 divided by 2 equals big B. And we're going to put parentheses, we need 1/3 of this, and also times the height, which we'll find up in here, which is 9. Okay, you can plug this all in your calculator, and you get 36. When you plug that in your calculator, it's 36, and it's meters cubed. The volume's always going to be cubed. On this one, it's kind of going to be the same thing. It's the same formula, but big B is going to be the base of is a circle, so it's going to equal pi r squared. Okay, we know the radius is 2, so we get pi times 2.2 squared, and then you have to times that by the height, which is 4.5. And when you plug all that into your calculator, you get 22.8 centimeters cubed. And that would be your answer for that one. Alright, let's try one a little more difficult. Now, this is again, it's a pyramid, but it's got a hexagon base. And it wants us to find the volume for it. To do that, we're going to have to be able to find the surface area for that hexagon. I drew a picture of the hexagon, and we know the side length is 4. Now, to find the area of a regular polygon, we use the equation 1/2 apothem times the perimeter. Now, the perimeter is going to be the length of the sides times the number of sides. So we know there's 4. P equals 4 times 6, which is 24. So we know P is 24. But we still have to find the apothem. Again, the apothem is a line that goes from the center of the polygon down to the midpoint of the base, forming a 90-degree angle. Now we can take these are going to be our 2 radii. Now we don't really know what either of those are yet, but we can find the central angle by going 360 divided by the number of sides. Now 360 divided by 6 is 60. So this central angle is 60. So we can break it into these smaller pieces, making this angle right here 30. Which means we have a triangle there that happens to be a 30, 60, 90-degree triangle. And we know this side is 2 because it's half of the side of the hexagon. So if that's 2, then we know that the long side is 2 root 3. Or in other words, 2 root 3 is 3.46. So our apothem equals 3.46. Now all we have to do is put in the equation. We get 1/2 times the apothem, which is 3.46, times the perimeter, which we already found to be 24, and we get 34.6. 34.6. And again, this is in yards squared. Okay, so that's just the area for the hexagon. Now we want to find the volume. So, but we found the area, or big B, so we take 1/3 times big B, which is 34.6, times the height, which is 11. Now, when I put that in my calculator, 34.6 times 11 divided by 3 equals 126.87. This will be yards cubed. I can't see it very good. 126.87 would be your answer on this one. Here's another example with just a cone. Now again, the base is going to be that circle. So we need 1/3 big BH. Big B is equal to pi times radius squared. The radius is 5. So pi times 25 equals 78.5. So now we go, it's 1/3 times 78.5 times the height, which is 8. We plug that in our calculator, and we get 209.33 meters cubed. And that's your answer for that one. Alright, here's another one. And this time they don't give us the radius. They just kind of put a triangle inside of our cone. We can see that triangle is a right triangle. This is 65 degrees and this is 16. We really need the radius to be able to find this, but we don't know it. It's here. But because we know this is a right triangle, we can use the trig ratios. And the trig ratios we're going to need is a tangent. So we know the tangent of 65 is equal to opposite, which is 16, over the radius, which we don't know, okay, or the adjacent. So we times both sides by r, and we get r tangent of 65 equals 16. Divide both sides by the tangent of 65. And we get r equal to, put in your calculator, we get r equal to 7.46 feet. Okay, now that we have that, we can find the entire volume. We know it's 1/3 times the area of the base, which is pi times 7.46 squared, times the height, which is 16. Okay, at this point you can plug that in your calculator, and you get 931.98. And 31.98, and this is in feet cubed. Volume will always be cubed. It's 3 dimensions. Okay, here's the last one. Now in this case, it wants to find the volume of the entire solid shown. Now, I'm going to break that into 2 different figures. First, we have a cube. Okay, and the cube's volume is equal to the sides, lengths of its sides, cubed. So 6 cubed equals 206. So that was easy. For the cube, we have 206, and we're in meters cubed. So we found the first one. Now we need to find the pyramid. So again, the pyramid is going to be 1/3 big B, which is a square. So I'm going to put 6 times 6. And then the height is also 6 times 6. Well, I know that's 1/3 times 36 times 6. I know 6 divided by 3 is 2, so 36 times 2 equals 72. And we're going to be in meters cubed. And that would be our answer.